fantastic. And you will speak about the best practices that work for you and hopefully will work for us as well.
Yeah.
So without further ado, the stage is yours.
Thank you. Let me share the screen.
Yes.
Okay, I suppose you can see the screen now.
Yes.
I don't have like an overview there, so I would just assume that. Okay, so my name is Jakub Nabrdalik, and as I said, I'm going to talk about the best practices. I actually had the title of best practices of this talk, but somebody stole that from me, so I had to use a different title. So there we go, simple and powerful. So the thing is that, you know, working with, after 19 years of working in this job of, you know, building the systems, I know a few things that I think are so simple and so natural for everyone, or should be, that if people do not use them, those things, I'm completely surprised. Why can't you do this? Like, this is so simple and will bring you so much power. But maybe they won't work. We'll see. So the thing is that all those practices, the good practices, are already there. You can reach out and basically read about them. The only problem is there are so many of them that people most likely have too much information anyway. And so all those practices are not well distributed. So I'll talk about those that work for me, right? And by working for me, I mean, you really have to be careful, because there is no such thing as best for everyone, right? We are different people. And so something that works for me perfectly well might not work well for you. So just be careful. My context, I design, build, and operate my systems on production. And with 19 years of experience, basically I do microservices the last 9 years. And I have about 9 years of DevOps experience, meaning that not only building those systems, but also operating them. And I help both the small companies and large enterprises, you know, doing consulting, but working as a developer and architect as well. And so these are going to be across all the board, but for a normal development team, these will be things that work when you build like enterprise class software in Java, for example, but they might not apply to you if you're a very small startup and you have different problems. So take this with a grain of salt. So now a situation. To discuss those practices, let's imagine we have a situation when we have a large system, event-driven microservice-based system. There could be 10 teams, there could be 100 teams, right? In a very complex domain. And so my team works with on the edge of the system. And basically what it does, one of the microservices that we have is importing invoices. You know, invoices, when there are users, they use different hardware, software, our software, the software of our partners. So those invoices are coming over between many different companies before actually somebody pays for them, right? And we have to import that. And we have a microservice for this among all 16 other microservices that my team does, right? And the current architecture, when we look at it, is something like this. Imagine this. We have a partner, which is another company, a separate company that sends our invoices. And there are actually many of those. There are tens, if not hundreds of those companies, right? And also our microservice called Invoice Importer here consumes 3 different topics to know things like to create kind of read models for, you know, what's the customer, what are the credentials, who can access this, what are kind of devices do we have that we can pay, so that we can verify those invoices and pass it over to the billing. So basically this handles the protocol, this handles, and it's a very fancy protocol, we have no power over it, it's a standardized protocol, and then we can verify, validate, you know, be able to basically do the importing logic and then pass it to the billing if the invoice is fine and everything's okay, right? So that's the current situation. Now comes the product owner and says, you know, there is a new requirement. We have a planning session here, and the requirement is very simple. See, I want to be able to upload the invoices from time to time as an Excel file, so that I don't need, and I want you guys to do all the checks that you do, because other than that, I have to do it manually. And those uploaded invoices that I actually have to do, these are corrective invoices. These are things which, you know, cannot go the official channel. So basically, they are partners. We cannot integrate with them in terms of corrective invoices, just because the author of the protocol didn't assume that there is such a thing as a corrective invoice, and so you cannot have an invoice with a negative value, but corrective invoices are exactly that, right? So right now the companies are sending each other emails, and in those emails they send Excel files containing all the information to create this kind of a corrective invoices. So basically they share it manually, and we want to automate this. Okay, so what's the first thing you should do? Well, the first thing we do is actually verify whether this makes sense, whether this feature will be used and is available to our customers. Because I wrote, like after 19 years of working experience, I think about 2 years I've spent working on the code that never got used on production or was basically useless, right? Just because somebody wanted this doesn't mean it actually is going to be used, right? So can you validate this? Can you prove that this is worth implementing, right? That's my question to the product owner and to the business side of my business, right? Of my company. And so let's check this out. Basically, first, let's find out how many invoices per month will we get. Because if we have 3 invoices per month, these corrective invoices that you want to automate, it doesn't make any sense to automate this because it takes about 15 minutes then for a single person to handle this. And it will never pay back when we automated this and we create a microservice for that, right? Then you have to think about, okay, what kind of data variation are we going to have? Because if there is no standard protocol and every single company sends us the invoices in a different way, this is an Excel file, but we can basically put everything in there, then that means that the maintenance cost of that code is going to be huge. Every single month, we will expect to have another set of invoices that are coming in a different format just because somebody pressed a different button in their Excel and basically exported that, right? So every single month you're going to have to basically fix that feature because it's not going to work exactly as expected. That creates a huge maintenance cost, meaning we are going to spend a lot of time basically working with that feature forever. And by working, I mean like keeping it live. So maybe that's not worth it. And then the next question is, okay, can we actually calculate whether this implementing this feature gives us enough money to cover the cost? Because developers are very expensive, and if this is something that you can do manually and basically can hire a student for whatever is the minimum possible wage, and basically they'll be happy, maybe that's better, right? Than actually paying for the developers and the maintenance for the next 3 years, right? So basically, these are the kind of things you have to calculate. And these are simple things that to verify and to check, but they are very useful to not have, at the end of the day, a useless code that you spend a month implementing, right? Now, so let's look at this feature. This feature looks like this. The manual processing actually takes 40k euros per month in terms of the salaries of the people who do it, right? So that's quite a lot of money, or maybe not a lot of money, but there's some money there, right? If we actually implement this, what will happen? Well, first of all, we're not going to actually be able to automate everything. They are still going to receive this as emails, and we don't want to automate that part. So due to different reasons. So maybe we'll save about 20k euros per month, right? So that's the money we're going to get out of this, right? The trust of the billing people in the billing is going to be increased because they're going to be happy that they don't have to do it anymore, right? Maybe there'll be some political gains because in large corporations, and we're talking about 20,000 people, there's always some political gameplay there. However, the cons are this. First of all, it's going to take, maybe 2 weeks of implementation. That's 10,000 euros, right? Or even a month, right? Depends on how much developers earn. Then we have a maintenance cost and the infrastructure, right? So let's calculate this as 250 euros per month, and it depends very much on your infrastructure and on the kind of the money that the developer make. And there is also the most important part, which is opportunity cost, meaning if we get to implement this in a month, like a single man month, then that means I'm not going to be implementing anything else at that time. So maybe there's something worth much more than 40k euros or 20k euros per month that I could actually implement instead, right? So this kind of analysis is very simple to do. Next thing is that when we get the requirements, well, the requirements are not ready to be implemented, because if you get the user story, something like I want to upload the Excel file, and maybe you get a nice mock-up of the interface. So, a button will upload the errors and then a list of the imports that you can download those errors and fix them, talk with your customers, stuff like this. So you're automating a lot, but not everything. Like communication, you don't do that. So if you have all of this, this is useless, basically. At this point, you have to refine the requirements. And that means basically writing them down as some things, or some kind of thing like a behavioral scenario, for example. I use BDD a lot, so that's behavioral scenarios for me. It could be use cases for you, but not user stories. Just remember, user stories do not gather any information, any required information. So we are writing now down the positive scenarios and the corner cases, or the negative scenarios, just to understand what we are doing and how it's going to work, right? And we have a list of all of those things. And these are just titles. I'm not actually implementing like the given when then at this point, just writing it down so I can understand exactly what I need to do, all the functions that it's going to have, right? And now, after doing this, let's move to the architecture. Hey, this is just a single feature. Like, why would we talk even about architecture? And I see developers behaving like this a lot. Well, actually, it is important. Take a look at this. This is just a single microservice that we have here, right? We could just push that feature, that new feature, inside this microservice and be done with it, right? It's simple. It's going to take a month, maybe 2 weeks even to implement, and that's it. But think about the consequences and think about how else you can do it. So, for example, if you add to this existing microservice and to its existing module inside this microservice, all those features of uploading an Excel file and basically parsing this and implementing the UI, what it means that you're going to add a lot of cognitive load. The current cognitive load for this microservice goes like this. It needs to, if you want to be able to work with it, you need to understand how to create read models from Kafka. You need to understand how to send events to Kafka. You need to understand how to validate the partner, the user, the service that is being for, or the device. And you need to understand how the invoices are presented and created on both sides, so on the billing side and on the external company side, right? And then you have the peculiar protocol that you have to work with. If we just add that feature into this microservice, this module, here's what's going to happen. The additional cognitive load looks like this. You need now to add Spring MVC, basically, if it's a Spring, in our case, it is a Spring microservice, right? To upload and download the file. That's not very difficult. The thing is, nobody remembers that because you don't do it all the time, right? So you have to reach out and basically read the documentation again. Now you have to parse this Excel file, and that's another library called Apache Poi. It's not a very difficult library, but again, you have to read that. And if you have to fix a bug when you're using it, you have to read the documentation again. Now, let's talk about a report. Let's say you're creating a report in CSV file, right? So a comma-separated file. Again, you have to remember how to create it, right? And it's not a difficult thing, but it's an additional thing you have to think about, right? And then you have to add a database so you can store this. But adding just a database, which is a simple thing to do, requires adding a library to migrate the schema, and you have to access the URL for the database, which means you have to access the vault or any place you keep your secrets, right? In the pipeline. So basically, you're adding a lot of small additional things that will increase your cognitive load, right? And whenever you touch that module, you will have to understand the whole list of all of that, right? So are there other options? Well, how about creating this as a separate module and basically not changing the module that we have, but creating 2 more modules? The architecture could look like this. In the bottom right corner, you see the invoice importer that we already have. That's the whole microservice is the box we see here. But we are going to add 2 more modules. One of them is going to be responsible for just uploading the Excel file and basically doing the validation. And another one will be the import reporter, will be responsible for basically showing the UI that the client wants to see the list of the manually imported Excel files and basically handle that, right? If you do it in the different modules, then this is what will happen. Inside of an existing module, the invoice importing module in this microservice, there will be no changes because we are going to call it as if it was an external partner. We are just going to add 2 more modules. One of them, when you work with it, which is called XLSX Uploader, you will have to understand how Spring MVC works with upload and basically the web. And also you will need to understand the Apache POI as a library that handles the Excel files. That's it. On the other hand, in the next module, importer, you will have to understand how to access the database, where are the secrets stored, right? You will have to change the pipeline. You will have to understand the CSV files and how you create them and how to handle errors, right? And that's it. So basically, we are splitting it so that whenever there is a problem there or you are implementing something, you can go to a single module and have a much lower cognitive load just because you don't have to think about everything. You don't have to remember all those libraries and all this documentation, right? So that alone is going to make it faster to actually implement and also much faster to debug and fix later on and maintain it, right? It also has a lower implementation risk, right? Because you're not going to change anything that already works within the invoice importer module. Okay, that's cool, but that's not everything. Because after creating like a simple solution in terms of the design, we have to analyze something else, which is how the software is going to fail. And you can do things like threat modeling, and there's a whole process for that, right? But right now, let me actually focus on one thing, and that's a job of every architect and every developer to actually be able to analyze how things will fail and protect the system against them. So think about it this way. When we add this new feature of Excel files, of handling those Excel files, we actually increase the attack surface of our system, right? That microservice that we have there, now it's going to have a UI endpoints, which means it didn't have the HTTP at all. It didn't handle HTTP in terms of the UI, right? Now it's going to have to handle that. So that's another attack area, right? Attack surface. Then we might have bugs in Apache POI. That's another library, quite complex. It's popular, but it's quite complex. You will have to be aware of bugs that are there. Then you will have the bugs in parsing. Whenever you're parsing anything yourself, you can have problems there. And of course, you can have memory leaks because those files are huge, right? So if you think about it, then we are increasing the attack surface of the microservice that we work with a lot, just by adding this small feature, okay? Now, what if we did it as separate microservice? So basically, we have exactly the same picture as before. We are going to have 3, but not modules. How about creating 3 microservices? One for XLSX Uploader, one for Import Reporter, and another one for Invoice Importer, or actually that one stays the way it is right now. What would happen in that case? Well, the attack surface of each microservice is much smaller, meaning each one is easier to protect against an attack, right? The failure impact is much smaller because even if you break into the reporting microservice, you can change the report. That's pretty much it. Like the information that are coming there are not going to billing, so you won't be able to cheat on us, right? And it's safer to implement just because we are not touching anything that already exists. We are creating new microservices. So that makes a lot of sense. Then you have to analyze the different quality requirements. Take a look at this. The invoice importer, the microservice we already have, that requires a high SLA, basically availability, right? It's got to stay there because it handles some load and it's important load. But it's not a large load. And there is a very low frequency of change. That microservice doesn't change much. If we add this feature as modules, or changing just if we add all those that feature inside the existing microservice, what that means is that the manual upload does not require high availability, but it might have a very large frequency of change. We don't know about it yet, but if it does, then we will have a very bad situation when, for that particular microservice, we will have a very high SLA and things will change a lot, and that's guaranteed to fail. If you have something where that changes a lot, it's very difficult to make it very stable, okay? If you have something that doesn't change, I can get that stable very fast, okay? And other things that come with it is, well, you will have another microservice to monitor, or maybe even 2, right? And maybe the memory consumption is not worth it, right? Because you will have to deploy it. They're going to be just staying there, and maybe that's not very used to often, right? So how about being able to scale it down to 0? Maybe do it as in a serverless way, which means that the cost per request is going to be much higher. But if it's doesn't happen that often, then you're going to save the money on actually having another instance, right? So basically taking the resources from your cluster. So basically, these are the things you have to analyze, and that's what we do, and it takes 15 minutes. And after we did that, for example, in this particular case, because it's a real case, we decided that the best way to do it would be actually to create those as microservices, but we are actually going to start with just the cheapest version, which is we are going to create a modules there, and we're going to remove them to the microservices later on, because right now we don't even know if we really want to have this feature for longer. Like we'll have to see how it works, basically, to analyze whether the maintenance cost is not too high. Okay, so but that cheap option allows us to change our mind later on. If we were just to add this as a feature inside that existing module, that would be very hard to refactor. Removing the module from a microservice into another microservice, that's much easier to do, especially when you think about it from the start. So that's what we did, right? Now, even with such a simple feature, the thing I would recommend right away, and what I always do, is we create MVPs, minimum viable products, right? So basically, we split even this very, very small feature into steps that we can implement, send it to the business, verify whether this is exactly what they wanted, works fine, and we can learn from that. So that improves the feedback. So for example, with this simple thing, we could have those two modules, the XLSX uploader and the reporting module, as two different steps. And we could deploy this to production and give it to our business right away, after just being able to upload the file. You don't have reports. You don't know whether it works well or not. Maybe you will see that on the billing side, and that's it, right? Or maybe we will actually return the response to you, but you will not have a nice little table, on the UI that you can check what's going on with the previous invoices that you have tried to upload. But that's okay, because even with the simplest possible solution, which is this MVP one, when you're just uploading the files and that's it, and then it goes into, so basically we're only handling the XLSX protocol and Apache POE, that will give us feedback whether this works well, the memory consumption is fine, and everything works, right? So that's just a half of our scenarios. That's very good, because we are now removing the work and getting faster feedback, right? Even for such a simple feature. So now this is the moment when we actually do the refining, which means now we are going to write given when then and the full behavioral scenarios for each of the requirements. So I got those requirements, right? We wrote them down. Now we are thinking about how it should work, what I should return in that case, how the system should behave. And I write all of this down, right? And I have several scenarios of those. And the important thing is I learn a lot even writing those scenarios, because like the first thing you think about, those guys get a large Excel files with a lot of invoices. And you think, oh, that's going to require a lot of memory and you reading that file. But if you even write it down, you will learn very fast that we don't need to do it, because Apache POE actually doesn't need to read the whole file into memory. You can basically treat it as a file, use the file system and basically move and you use just a part of that memory to read the data that you need and just throw it away. And also other features might not be important for us because we already have them covered somewhere in the system. So basically, analyzing this allows you, like writing it all down, how it should behave, verifies your assumptions very quickly, okay? At this point, what I do and what we do is we create a report from this scenarios. So basically what you see here on the right side, this is a library called Spock Reports, which creates a beautiful HTML file, okay, which describes all those test cases or behavioral scenarios that you just wrote down as tests, right? And this is readable for a human being. This is readable for the business. And every single test library these days have got this kind of tool. I'm using Spock, which I can recommend a lot. And this is Spock Reports. Now, what goes with this? At this moment, I send this back to the business. And I say, guys, this is how we think it should work. Is it exactly how you think it should work? Please check this out for me, verify this, because take a look at the last line in the bottom right corner. We know there'll be some errors within those files, that other companies sent to us. But what kind of errors have you noticed so far? Because we don't know how many we should expect, and basically what kind of an Excel specific errors should we protect against, right? So they will read this, they will verify our assumptions, and they will send back like a typical list of the errors that they find, they can think of, right? Which will help us tremendously in terms of, preparing to work against that. And the best thing is, we didn't even start to write the code yet, right? Before we wrote the first line of production code, we have to prove the validity so that we don't write useless code. We designed the architecture. We have optimized the architecture for minimum cognitive load, meaning always that it's going to be faster to implement. We checked different quality requirements, look at alternative solutions in terms of the architecture. We designed the system for failure. So basically we assume how it's going to fail, what the risk is. We split this solution to MVPs, and we refined the requirements with behavioral scenarios, which allows us to send those tests as basically a way to manage requirements and to communicate with the business, even without writing a single line of code. And the best thing is, if you think this is a lot of things to do before coding, that's 1 hour of work. This is a lot of things to do if you're starting out, if this is the first time you do it. But after a while, you can get all of that in a single hour, right? So with just 1 hour, we have verified all of these things, and we can save a lot of time of actually implementing something that's useless, or implementing something in the wrong architecture, or basically miscommunicating with the business just by sending them the behavioral scenarios. So I always do that, and I would recommend this. So now we move to the implementation, right? Here's the problem. A lot of developers actually think in terms of they are kind of a plotter machine, right? And so they write the code, and it's perfect code. We are professionals. We should like get the solution done, clean solution done first, the first time you try, and it's over, right? That's not how creative professionals work, okay? The thing is, if you have a complex solution, then the senior developers, when they see it, quite often they choose the tool or the patterns or the architecture they already know, they are familiar with, right? And that doesn't have to be the best one for the problem that we have. It's going to sort of work, but we can hurt ourselves a lot. If you have junior developers, what happens is that they quite often just get completely blocked, and they say, I don't know how to start it. This is too complex, right? Or maybe even worse, they say, yeah, I'm on it. I'm trying to do it. And then you ask them the next day and say, on the stand-up, and basically, how you doing? And they say, yeah, I'm still on it. And the next day, and they say, I have no idea how to actually start it even, right? So here's the thing. How should we start it when you have a complex solution that is not trivial, right? There are many ways of actually getting these things done. The first one I can suggest, for example, is the baby steps test-driven development, which Sandro Mancuso is actually the best example of. Actually, you can learn it from him the best way. The way it works is that if you don't know how to, if it's complex, you don't know how to implement it, how it should work, then take that behavioral scenario like we have here, the long one, right? That explains what should happen when everything's fine. And maybe just split it up into several scenarios, or maybe just take the first one and just try to implement it. So here, for example, we take the scenario for our importing module, and we say for our XLS6 upload module, actually, and we say that it should send, at the end of the day, it should send the information to the reporter so that the reporter can show something. Implement just that. That's pretty simple, right? Then take another one. Okay, so that report that we sent should have a file name, right? Implement that. You're going to learn that this is very simple to do. So we are moving with baby steps, right? Then it should have a username. So implement that. Where do I get the username that is currently using the system, and so on, so on. And step by step, you will have all of this implemented, at least till you hit something very difficult. Because if you hit something very difficult, then maybe split it into even smaller cases, like here, for example, when we are thinking about the different error cases. We have here, you have a parameterized test. If you're not familiar with that, there are just several cases here, but they look exactly the same, because the only difference is the expected error that we're going to get from a wrong file. And we prepare with this and work towards the goal, right? Now, baby steps are great. They are really good if you're stuck. And basically, they allow you to move forward, always move forward, very slowly. There are a lot of iterations, but just move forward, make another step that can get you there, right? But also it can be infuriating, because when you already see this after several years of experience, you already see the solution or part of the solution, you don't want to move so slow, right? You want bigger chunks. You want to implement those bigger chunks because you kind of see them with your mind's eye, right? So, and at the end of the day, the important thing is take all those small scenarios, and we'll have to put them into a single test anyway, just because, working with the Excel files, meaning touching the I/O, and touching the I/O is very expensive in terms of how long it takes to actually open that file. So maybe just have all those scenarios together. But it's a way to open up your mind, right? There's another way. Another way is the backward programming, which means start from the very end of the implementation code. Basically, start from the last line, okay? Take the positive scenario, start from the last line, and see what you require, what you need to do in terms to be able to provide the solution to that problem from that last line. So, for example, this is a full test of all the possible steps in the scenario of uploading the Excel file. How about we implement this with the backward programming solution, right? So we would start with the end and say, okay, I need to return the result. That's what we are going to see on the web, right? And so where do I get that result from? Or maybe I need to send it to the reporter as well, right? So now I have to implement the method called send to reporter. So maybe we should send it to the reporter only when it's successful, when we have at least one invoice imported from that Excel file, right? Because otherwise it makes no sense. So we got that implemented. That's trivial to do, right? Next step. Where do we get the result from? Well, we have to create the result. What kind of data would we need to create that result? Maybe the number of the successfully imported invoices, maybe the failed rows, so we can show them that they are wrong, right? And the problems that they have. Maybe the file name and the username, so we know who imported that, and basically we can show it on the reporter later on. Okay, so now we got those 4 different variables that we need to get somehow, right? So let's think about them. We implement this method and we actually move forward. Now let's create those variables. So we know that we need to convert and export the workbook and so on, so on. So you think in terms of what should I do at the end? Where do I get that data from, right? And you're thinking in terms of small steps. That's very helpful to open up your mind if you don't know how to do it. And basically, it allows you to focus on a single thing, just like with the baby steps, but it's very natural in terms of it brings you to a solution that has got like very small methods that are actually well implemented. And the only downside is actually the whole main success scenario will not get implemented until you finish the whole thing, right? But you will see it goes further and further. Different steps will be implemented one by one. You can get stuck in the middle though. So you got to be careful, because if one of those steps is way too large, then it's not enough to actually think in terms of, I'm going to, where do I get the variable or data from? So this is where you can use another technique, which is, high-level design and then filling up the details, which means how about approaching this problem by just, writing down in a perfect world how it would work in terms of the code without actually going to the details, and then finding out how to implement this. So let's try that out. Let's see how that would work. You would create something like a, high-level method when you do a lot of, when you call a lot of smaller methods, but basically the way you think the algorithm should follow, right? So basically, okay, I have a file, okay, so I need to open a workbook. Maybe I need to take a Excel sheet, right? And then I need to convert those rows. I don't know how to do it yet, doesn't matter, but I need to convert those rows. And when I have those rows, then I will try to export them to the billing or the importing module actually, and then that will create some kind of a result. So maybe I'll need to actually change this to a class, to an upload result. Then maybe I need to send it over to the reporter and then return the outcome and so on. So basically, we're designing the algorithm from the high level and then try to implement this, right? That also helps a lot, but the problem is, and this is where you have to be careful, the reality is much uglier than your high-level vision of the algorithm that you're going to get. So in this case, for example, you have to handle a lot of runtime exceptions that can happen when you're opening the file and also when you're working with the Apache POE, because they happen. The data is usually problematic, and this is real-world data, meaning there's a lot of things you assume are correct, but they are not. Then you have to think in terms of, if I do it this way, and then I actually read the whole sheet and maybe all the data, what would if they have like thousands of those invoices in a single file? Then I'm going to read all those exported rows. That's a lot of memory. So maybe I should use it in a streaming style, meaning let's use Webflux, for example, in Spring, so that we can parse this step by step in a streaming style or functional way, instead of loading all of the data into the memory. And you are not going to get that from the just high level algorithm that came into your mind. You have to actually think about the details of the implementation, the consequences there. And there is another way. If that's not the best way, well, how about this? This is one of the techniques I've learned as a student. This is just playing by fucking around with it. And what we would do in such a case, let's just start implementing this method, right? And we would do something stupid, completely stupid, like, throw some exceptions, see whether it works. Can I even open a file? What happens if I open a file? What happens if it's wrong or it's incorrect, right? And then maybe add another method which says, okay, what if I want to open a sheet? Can I actually look at it? And I don't even know what to do with it, so I'm going to just log it out or print it on the screen, basically. And then let's try to parse those columns, right? And so this kind of a very ugly, completely not production-ready code is being created. So so how is it a technique to actually help you implement something, in a professional way? Well, because that gives you a lot of feedback. You learn how to use the library. You learn how the library works, and you are not blocked just by trying to be perfect all the time and just trying to be, to find the best solution. The important thing here is that you will get the feeling of how things work, so you can actually implement them later on better. Just don't push it into your repo. That's it, right? But you can fuck around, you can play with it, and it sounds stupid. It's not stupid, right? It helps you a lot in terms of understanding how things work more or less before you define actually what the solution, your preferred solution, is. And so these are the techniques that can open up your mind when you're stuck and you're thinking, oh, I need to solve this complex problem. What do I do? And I'm like 2 hours later, I'm still stuck, right? Just choose one of those techniques and try it out. So which one should you use? Actually, all of them, because neither of them is as a good solution to the problem, right? They do not provide you with a good solution to the problem. They provide you with the steps to understand and open up your mind enough so that you can actually come up with the perfect solution later on, because we are not plotters. That's important. This is how you think the developers work. They will put the perfect lines everywhere. They never modify anything. They don't change anything. They don't delete anything. And they come up with the perfect solution because, this is how you would apply for Google, for example, and you have to come up with this whiteboard solution right away, right? That's not how people work, okay? If you want to see how creative people work, people that have to come up with the solution themselves, like, for example, graphic designers, right? My sister is a graphician, and basically what happens is that you create a lot of drafts, and you get there by trying things out and getting closer and closer. But you create those drafts and step by step, and you don't understand yet whether this is something you are going to use. So you throw it away and try again, okay? This is what you think about the programming. Like, we will just design something and then we implement the perfect solution, or maybe refactor it later on, okay? But actually, that's not how it works. If you try to do it this way, just implement something and then refactor it, you will find out that it's very, very difficult to refactor a very shitty code, okay? There are techniques, of course, for that. But if it's complex, then at some point, there'll be parts of it that you are not going to want to change just because changing them is difficult, or maybe not difficult, but requires a lot of rewrite. So why would you do it? That's, again, a wrong expectation. Do not assume you're going to write the perfect code the first time. Actually, assume exactly the opposite. If you try to implement simplest possible solution and a refactor, the part of the code will be fine, the other part will stink a lot, okay? Instead, do this. Try to create different drafts of the code, basically, and then delete them. And I see so little of this technique in terms of how many programmers basically do not like to delete their own code. But you can fuck around and play with your code. with your solution, just to understand what are the possible implementations. What if we did that? What if we did this? Without stopping, basically stopping and trying to think out the perfect solution. Just play around, delete all of this and try again, because that's exactly how your brain works, by creating a lot of different variations and then choosing one. But to be able to create those variations, you have to see them for yourself. You have to see them with your own eyes. That's how my sister works. Basically, every graphic designer, they make a lot of drafts, okay? And when they have those drafts, then they decide, okay, this pose is actually the best. I'm going to implement more details in this. And they look again, right? And they have no problem actually throwing out away the work that they do. And a lot of people think in terms, nah, good people are perfect. They design something in the perfect way. This is Bob Ross, the guy who actually in American TV years ago was showing how to make mistakes by implement a painting, or basically paint by making mistakes. And so you would see him basically doing a painting from the scratch, and explaining to you that every single mistake he makes is actually an opportunity to be able to use, and you don't have to stop at this point and just basically be happy and follow whatever you got on the canvas to be able to get it into the working condition. Unfortunately, that's all bullshit, because he didn't work this way. Every time he was showing how how professionals work, and he would get the perfect painting at the end. Actually, that was his second painting. With every single program that he did, he would first draw this thing at home, paint it at home with several tries, and later he would actually move to the studio and show everything, how it's beautiful and perfect to be able to do that. And right now, the same thing happens when you're doing this with, for example, conferences. You see Josh Long, who is a very nice programmer and a great person, and you see him implementing stuff live. This is live coding, very, very fast, right? And you see, oh, that's how it should work. This is exactly how I should do it. Well, Josh Long does it because he did it the same piece of code. He wrote that same piece of code 100 times before, because he does a lot of that talking, okay? So he gives a lot of talks at conferences, and this live coding is so quick and so fast and so precise because he did it already several times. Normal people don't work this way, right? You fuck around, you find out different solutions, you choose one, you delete the code several times, and then you move forward, right? Just don't stop at writing. Okay, and think about it this way. Ernest Hemingway wrote that, don't get discouraged because there's a lot of mechanical work in writing, in coding, definitely, right? Because he said he rewrote the first part of Farewell to Arms at least 50 times. Okay, think about it, right? And he said the first draft of anything is shit. So if you write, the perfect solution the first time, most likely it's shit. It's just you think it's perfect solution. Try with the different approaches, delete the code, try again. It's going to be much faster than you trying to think out the perfect solution from the scratch. Okay. So here are my best practices for actually coding. Fuck around a little. Explore possible solutions, implement them, okay? You just don't stop yourself when you try to implement it, because remember, you're gonna delete it before you actually push it to the repo. Try to implement it again, get closer to possible solutions that you want to use, repeat it over and over again, and don't be afraid that you're wasting time. You're not. You're learning. You are learning what the code could look like, and you're learning what the code should look like by comparing different solutions that you did, okay? And if you think this is slower, and I don't have time for this at work. I just say, everybody's pushing, I need to write it. Listen, this is actually quicker, okay? Because if you're trying to be perfect at work, then you're stopping a lot in terms of thinking about, maybe I should do this or that, and you're afraid, and you're stopping yourself, right? Here, you don't give a shit. You're not stopping yourself. You're just trying things out. You build a lot of abilities, basically, and muscle in your brain to be able to choose which way you want to go and to be able to provide the solution later on, right? You're not a plotter. You're not putting perfect lines. You're like a graphic designer. You learn by making mistakes. That's how our brains work. Make mistakes, and you learn from that. Just don't push it to the public repository. So Rewriting and implementing this over and over again is actually quite fast because most of the time you actually spend on thinking and reading, not putting the code in terms of clicking on the keyboard. So that's how it's going to help you also with basically being able to delete your code, because you learn that you don't get attached when you know that you're going to delete so many things. And that helps you a lot because you will learn egoless programming, which means the kind of programming when you don't feel responsible for, you don't feel that your code is the perfect code that can get deleted. And basically, it could be anyone's code and it's all that same and it's good if it works and you don't have a problem with maintaining it, then it means it's not bad, right? So these are the techniques for programming, but it's not everything, because at this point, when you're done with programming, there's one thing that a lot of people actually forget, and that's, well, your system. This is the map of the whole galaxy, basically the whole visible universe, right? The universe is expanding, which means that we are going to see less and less of it, and the less information we will be basically able to explore less, even though we have like new technologies, just because the speed of the information and the speed of the expansion of the universe, the speed of light. So this is the whole universe. And unfortunately, at this point, if you stop, your application is beyond the event horizon. We cannot see shit when it works in production. You cannot understand anything, how it's going to operate in production, except for your tests, right? So what you forgot about, and I see people doing this over and over again, is not adding the observability here. So what do I mean by that? Take a look at this simple piece of code, which a lot of programmers would say, this is perfectly fine. This is completely cool, right? I need to send the report to another module, which is called reporter, right? And I'm going to do it only if the successfully imported are larger than 0, meaning I have actually imported something and are not just all the errors, right? And that looks fine, except what will happen in production if the exact number of successfully imported is 0? Well, nothing. You will not know about it. You will not even notice this, okay? Maybe there'll be a message to the customer, to the user, but in the logs, you will not be able to find out. When somebody calls you and says, I tried to upload this file and my web page showed something, but I just clicked refresh and it's not there anymore. And I cannot find any of those invoices. What's going on with them, right? And you will not be able to say that as well, just because you're not doing any observability at all. So the correct solution will be to actually add a log on every single branch of your code, not every single line of your code. Do not add log on every second line, but on every single logical branch, which means, okay, when this code happens, this code runs, right? If I don't see the outcome in terms of a report on the reporter side, I will see the outcome and the decision that the code made, which means I'm not sending it because there's nothing interesting in it, in the logs at least. So I can explain to anyone that needs that what kind of, what happened exactly. And this is a very important part of your job that a lot of people just completely forget about, because you will have that situation when you will have to explain what's going on. You will have to understand how your code works. But to be able to do it, every single branch of your code has got to be visible, observable somehow, either by the outcomes or by logging, if not, okay? If you don't have an outcome there. So if you add this and then you put this on the metrics, and on the bottom right side, you see real world metrics from exactly that microservice and this type of code, then you will be able to reason about what's going on with your system, what's happening, basically, how people are using this. And if you don't put those logs in those branches, then it's a problem. And there is a lot of different branches, where code branches or basically execution branches that you would skip, and I see a lot of developers skip. The example is if-else, right? You don't put an else there. If nothing happens, the if just got skipped, but you don't know that it got skipped on the production. Then there are optionals of nullable, meaning if I don't have anything, the methods on this monad will not work. The same with mono empty, for example. The same with Kotlin let, right? So basically, there's a lot of different paths, different ways of how you can implement this in code, and you will never notice that something wasn't done, because you're only focusing on the positive scenario, and you want to be able to say, hey, that didn't work on production, and I know exactly, because at least I got logs or metrics telling me exactly that, right? So you have to always add this into your code, but don't just add, just do logging on so that it clutters your code. Use clever methods. Here, for example, you can see something called a higher order function. The first two methods of this code with logged user and with movie details actually handle the corner cases with reporting. So what I mean by that is that this code, the top method shows the interesting part, saying I need to understand what the algorithm is. I need to understand how the float goes, right? But when something goes wrong, I have those methods that will actually handle the corner cases and log something apart just from throwing exceptions, basically, or returning an error, right? Because remember, on production, you really want to be able to reason about what's going on with your system, because production, a lot of different things will happen. So if you're a DevOps, you definitely need to do it, okay? Now, there's another thing I can suggest in terms of, we are coming to the end of the time, but I can really suggest is try to run your tests. And when you have an error in your tests, don't run a debugger. Instead, turn on the logging and basically see if you can reason about what happened, what wrong happened in your code based on logs alone, okay? If you can while running tests, find it in your logs, then it means on production you will be able to do it the same thing. So you'll be able to reason about what happened. If your logs do not give you enough information, then on production you will have exactly the same situation. Something will happen, you have no logs, you cannot reason about it, right? So instead of using a debugger in your IDE, what I suggest and what I do right now is I use the logs to be able to reason what's going on. And here, to do it properly and to have this kind of a very nice looking logs that explains it step by step, you have to be very careful, because by default, those logs contain a lot of shit information. Basically, a lot of spam is there, right? And if you just try to add your logs into this existing spam, it's going to be very hard to find anything. That's not what you want. You want to have only the interesting parts of the information that you need. So how can you achieve this? This is what I would get by default using the libraries, right? But I need something else. So I would recommend playing with basically the logging library. I use Spring and I use Java. So and with Spring Boot, that's a logback. I add a file like this, a logback test XML, to the resources, so that I can have a proper logs even when unit testing. There is no Spring involved, so we cannot just use application properties or application properties YAML or something like that, right? But I want to have good logs just on the unit level and then integration level and then in production. So I would put this kind of a file where I actually copy paste the Spring schema for the logs, so I can have them exactly as I will have them on production, and then I can reason about the logs or the failing test based on the logs alone at this point. And I highly recommend this. It will save you a lot of time later on production when you don't have anything, then don't have any observability, and you have to somehow explain where the hell is that single invoice that actually costs 2 million euros and you didn't get it, and what happens next. So that's important. Okay, I think we are running out of time, so I won't give you more hints about how to do a mob code review, unfortunately, like with my 2 cats, which is a beautiful thing and that usually helps. But I'm leaving you with the slides so that you can read the rest of the part, because there is also how you can break the code with debugging and with how you should actually approach debugging and fixing on production. But at least I'll give you this. Basically that. Before the code, this is the list of the things that I would recommend. While writing the code, here's another list of doing that. And after the code, at least add the observability at the end while coding. But basically, there are 2 more techniques I didn't have time to mention, which is mob review and a scientific method for actually analyzing the errors. And you can find it later on in the presentation, and here are all the links, and I will pass them as well on the chat so that you can copy paste them and use them later on. Thank you.
Jakub, this was perfect and such amazing start. You will find a lot of questions from a very curious audience, so congrats, you made the people curious. We had almost 400 people all the time, so you kept everyone engaged. And yes, thank you a lot. And I suggest everyone just take all those insights, go to your teams, check them out, and copy paste what makes sense for you, because of course it was crazy good practical. Thank you so much, and thank you for the audience to being active. So have a very good day and check the questions in the Slack.
I will. Thank you.
Thank you. Bye-bye.